All right, so today is no new content or anything. It's just a course retrospective, and a retrospective is essentially what went well, what didn't go so well, etc. So remember, we are on Piazza if you have any questions or comments or sad goodbyes as I wrote, all right? Again, a course retrospective is what went well, what didn't go so well, and what can be improved for the future, right? So from your perspective, your opportunity to say those things, to identify those three things, is your course evaluation. It's especially important for this past year where we've had this hybrid learning model where we've had a handful of students in the class, two today, and we've got a couple dozen more with us online. Frankly, this is how I was doing it beforehand. I was streaming or recording lectures for at least the year before COVID started, and it worked back then. It's worked somewhat well this semester, and I'll continue doing that. So if you have feedback, on my setup using OBS or anything else like that, please let me know. If you have any comments on how Canvas is set up or how we've used GitHub, et cetera, please put in the constructive criticism, of course, in those course evaluations. I do take those seriously. I take them, I take them personally serious in that I do a lot of analysis on it, like what went, the three things above, right? What went well, what didn't go so well, and what can be improved for the future. So if you've got ideas, please share them with me. And I take it so seriously that I really want a high response rate. There are 135 people that have been given the link, or the link is available in Canvas, of course. 55 as of this morning have filled that out. And as previously announced, if you filled both this and the other evaluation out, the Learning Assistant Program evaluation out, then I'll give up to 10 points based on that response rate. So with 55 out of 135, that's 4 points, right? And 10 points is nothing to scoff at. That's 1% of your grade, right? That could mean the difference between a plus or a minus or a plus or whatever, right? So do be filling those out, and you have until Friday, and then that's when I will set the bonus points based on that, right? So what have we done this semester, right? Take stock of what we've covered and what skills you've picked up, etc. Hopefully you've picked up a lot of more soft skills, teamwork, conflict resolution, and coordination, especially in the post-COVID world, right? I've seen comments from a lot of students and a lot of individuals that absolutely hate teleconferencing. Teleconferencing has been a promise for the last 50 years, frankly, right? It's been like, oh, wow, we need to have the technology to be able to teleconference so we don't have to move all over the place. And now that that's a reality, you hear a lot of griping for some reason. I don't know why, since everything's turned on a dime now and we don't want the future. But frankly, that's the business future. Businesses have realized that they can save a hell of a lot of money through teleconferencing by not paying for overpriced offices. I was just introduced to a company, a VR company, that came to our class a week or two ago, and they gave me their business card and said, if you have any prospects, people who want to develop in Unity and VR, let us know. And I looked at their card and I said, oh, well, you're in Los Angeles. That's kind of a big ask for an internship to move out to Los Angeles or something. No, we don't have an office. That's just our headquarters. Everybody in that company works remotely. So this is the new reality, folks, right? That your jobs will probably involve a lot of coordination across the globe using teleconferencing technologies like Zoom, Teams, whatever, right? The technology will change, but I think that we've hit a fundamental shift as far as COVID goes with teleconferencing. Hopefully you've also picked up some teamwork skills. I know a lot of people have picked up conflict resolution skills because there are at least a half a dozen teams, pairs, that didn't really work out. Right? As I said in the very beginning, right, that somebody can drop, somebody can flake out, somebody could have cheated all the way through Computer Science 1, and they don't really know how to code at all. We saw a lot of people, not a lot of people, but we saw a good number of people having to deal with bad partners and bad partnerships, and how to come up with conflict resolution, that you need to be pulling your own weight. And if you're not pulling your own weight, then I'm going to have to, pull out and not have a partnership or find a new partner, right? A lot of those people ended up with decent partners after that, right? But you have that comes with experience, right? Those are people skills. Those are soft skills that come only from experience. I mean, some people claim that you can teach those skills, like you can write a book and a chapter on, well, if this situation happens, you could respond like this, right? And those are helpful in knowing that there are options out there, but ultimately at the end of the day, it really means, you have to experience that in order to build that inner bravery in order to tell somebody to screw off, right? Now, you're not always going to have that luxury in your job, right? Because you're not going to be the boss. You don't have the power to fire somebody. You don't have the power to not work with somebody. But these are valuable skills that you'll eventually have, where if you do have a bad a teammate or a bad coworker or something, how do you deal with those, right? And hopefully we've given you a glimpse into what that might look like. You've increased your toolbox, right? You have a second, or maybe in some cases a third programming language. You have experience in an object-oriented programming language. Your fourth programming language potentially is SQL. SQL is a programming language, right? Hopefully you've also gained more skills through Git and using an IDE and stuff like that. So a wide variety of toolbox skills, hopefully, that you've picked up. You've had exposure to proper formal unit testing in the form of JUnit. Hopefully you think about using that in the future as you develop your own more substantial projects. You have experience and perspective building a larger project, right? Now, it's still a toy project, because we can't have you build, remaking Facebook or something like that at scale. And we have to hit on, the basics. But you do have some experience of building a basic CRUD application right now. CRUD being create, retrieve, update, and destroy. You also have some technical writing skills, right? You have by maintaining your design document throughout the semester, hopefully that gave you the experience you need to understand that design should come first, right? The questions that you should be asking yourself, what data structures should I be using? How are we going to go about this so that we don't paint ourselves into a corner and have to throw everything away? Prototyping, right? Coming up with a first solution, realizing that's not ideal, going back, refactoring, changing, and redesigning things, right? If you didn't take full advantage of the technical writing design document, definitely try to do that in the future, right? Hopefully you also have better appreciations of things I've been talking about throughout the entire semester, but better understanding of technical debt. That if you don't find time to do it right the first time, you'll eventually have to find time to do it over. Or eating your own dog food, right? If you had a bad design in phase 1 or phase 2, then you ended up fighting that design throughout the entire process, or having to go back and redesign it so that you didn't have to fight with that design, right? Some people are finding out now that they had a really bad design because it's making it impossible to design a sorted list for sales, because they never had the functionality that a sales total should be part of the sales class, etc. Bad practices became apparent why they are bad practices if you followed if you got into the mistake of doing those bad practices, right? Design as an afterthought rather than design coming first. That's bad. The usage of good test cases, good test suites, etc. Those are good. We tried to emphasize that through exposure by showing you here are a bunch of JUnit tests, right? If you had designed these tests for your project, think of how much easier that would be, right? If you had started out with those unit tests on phase 1 or phase 2 or something, you could run those unit tests throughout the entire process just by clicking a button. Did I break anything, right? It also would have allowed you to design the actual classes themselves, because if you have a test case here, that kind of informs your design of your classes. How am I going to test this class? Well, I need to know that there's a sales total. Well, that means that when I design this class over here, I need to put in a method called sales total, right? Something like that, right? Poor variable names, not that big of an issue that I saw this semester, but in another class I saw some really bad variable names because they were completely named something different, and it took us like 10 minutes to understand each other. Like they were trying to troubleshoot. They had some questions about, well, this is not working, and I'm looking at their code, and they have a counter for something, and so I assumed that it was one thing. Well, and then finally we got to the point where, well, what is this a counter for? Well, it's a counter for this other thing over here. Then why didn't you call it that? Because you gave me the impression that this is a counter for something else by calling it something else, right? I'm not going to go into too much details there, but that's a situation that you can get in with something very simple like poor variable naming, right? Over-engineering. Remember the Yagni principle. You ain't going to need it, right? Don't over-engineer until you absolutely need to. Bad database design. We didn't see a lot of that this semester. For some reason, a lot of the databases were they followed our instructions and advice, and had a single inheritance table and strategy. They normalized everything almost from day one. For the most part, that was almost I think that the average there was 90% on that phase. Great job, everyone. You have a better appreciation for the scope of a larger project, again, working and coordinating in teams, etc. Hopefully, after your first year, of course, you're better coders overall, you're better designers, and that'll serve you going forward. Okay. So, you also might have experienced some other bad things, right? That procrastination is never going to be a good thing, right? You're still, let me level with you, you're still in the insular world of school, right? Where if you don't get a project in on time, maybe that's one bad grade. If you get 2, 3 projects not in on time, well, then that's probably a failure in the course, right? But it doesn't mean that you're kicked out of college. If you fail, if you take a real job and you don't perform for 2 weeks, if you just sit there and do nothing for 2 weeks, you're not going to have that job much longer at all, right? So pull out your resume, don't use them as a reference, and start over. So procrastination in real life is probably not an option, right? But you're still learning. You're still in college. You're still learning to self-manage and build that self-discipline so that you don't experience that in real life. And hopefully we've given you some tools that you can use going forward. For example, using a Gantt chart. I don't know how many people ended up doing it, or how many people ended up following our near daily updates on Piazza about what you should be doing right now. But hopefully that at least exposed you to at least one tool. In the past, I've exposed students to the Pomodoro Technique. And the Pomodoro, all of these things can be used in all of your other classes, by the way, right? It doesn't have to be just computer science or project management or something like that. The Pomodoro Technique is where you need to study or you need to get on task for multiple things. Like you've got 5 things that you need to do today, right? A Pomodoro Timer basically builds in break time for you. So a Pomodoro Timer is like 30-minute egg, well, we would call them egg timers, but it's a Pomodoro, I think Pomodoro is a tomato of some sort, right? Anybody look that up for me, please? But it's shaped like a tomato, and it's a 30-minute timer. You focus on one task for 30 minutes, ding, take a break, or context switch out and do something else. So that you're not always, you're not barreling through and doing something for like 3 hours in a row, because your productivity, if you end up doing the same thing over and over and over again for a long time, yep, that's it. It's a tomato. It looks like a tomato, is it? Yeah. Okay, it's an Italian tomato. Okay. So anyway, if you focus too much time on one thing, then your productivity goes down over time, right? In that 3 hours. And that's why I gave you the Gantt chart, so that you're not waiting till the last minute and chunking everything. Okay, I've got it's due in 5 hours and I haven't started. If you work all the way through that 5 hours, your productivity goes down, 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 right? and you hit a roadblock, you hit a bug that you can't solve. Well, if you'd started much earlier using a Gantt chart or something like that, and did it in chunks using, say, a Pomodoro technique, then that means that once you hit that roadblock, you say, okay, I'm done. I'm not going to think about this. I'm going to go and do something else. Because usually while you're doing something else, something snaps in the back of your head and says, that's why, of course, that's what the bug must have been, right? Because the very act of not thinking about it, all right, is very Taoist. If the way of not thinking about it ends up, okay, now I understand what it is, right? Thinking about it subconsciously, basically, right? You also have seen the problem with insufficient testing, right? A typical Piazza post will be, it's not working, right? Well, why is it not working? None of us, we're not going to know because we don't know your code base. We don't, even answering the question, how is it not working, requires some testing, right? Well, it's not working because this particular variable was null. Why was that particular variable null? Because you never set it up here, right? You have to have that kind of investigative attitude where you trace throughout your entire code. And to even be able to do that, you need a test case in order to run to reproduce that error so that you can actually, investigate it further, right? It's like without a test case, it's like a murder investigation where you don't even have a body. You don't even know who was murdered. How are you going to determine who did it if you don't even know who the victim was, right? A test actually allows you to investigate further because now you have some evidence that you can actually use. Right? If you can run code, you can run tests. That's basically what the labs were. We provided the tests. We provided the JUnit tests. If you can write code, you can run repeated tests, right? Because now that you've written it and you do an ad hoc test, okay, it looks like it works, right? If you ever break anything, then you come back and you have to do that ad hoc test again. You have to do all your work over again, right? And so it's much better to put that into a repeatable unit test framework, right? So that you could just hit a button and rerun those tests as many times as you want. If you can read code, you can write proper unit tests. And note that I started with run, write, and read. Reading code is actually a higher skill level than writing code, right? It's kind of an if you know Bloom's taxonomy, it's kind of an inversion in computer science because up here, Bloom thinks creating something original is a higher cognitive skill than simply just looking at and evaluating and analyzing something else, right? Well, it's actually just the opposite with coding. Because it's far harder to read and understand and grok somebody else's code than it is to reproduce your own crappy code, right? Being able to recognize, oh, wow, that's beautiful code, right? And understand it at an intuitive level, that's a much higher skill than simply just writing code, right? These are the skills objectives that were originally in the syllabus. That you should be able to more easily pick up a new programming language on your own. If you take 310 next fall, I'm not sure it all depends on the instructor, but usually there's a third programming language there. If it were me, I'd say Python 3. Learn Python 3 as your next programming language. I like the approach of starting with a difficult language, C, then approach another less difficult language, Java, and then approach a much easier programming language, Python, because if you start with like a bare bones programming language like C, then it really forces you to focus on the concepts of the programming concepts themselves. Once you're up here, right? Once you've progressed to the point where you need to understand the data structures and algorithms, you don't need to understand those base programming concepts at all. So go ahead and use a programming language like Python, where it's a little bit easier and more approachable. Right? Otherwise, that's usually inverted with mostly non-majors, and unfortunately, a lot of institutions take the opposite philosophical approach. Let's give them something easy, and then progress them through. Right? You should be able to recognize, use, design, and appreciate programs with an object-oriented flavor. Right? That you should approach the problem and say, what objects, what entities do I need to model this problem before I decide how they behave and how they interact with each other. Be able to design a database back-ended application from scratch given a general problem statement. That's exactly what you did throughout the entire semester. You should be able to understand and implement basic data structures, as well as recognize how and when to leverage appropriate simple data structures and algorithms, of course. Remember, just like sorting, don't roll your own. In real life, you won't ever probably implement your own sorted list ADT like you're doing right now. But you do need to do it at least once to know how it's done, right? It's like rebuilding, not everybody rebuilds a car. I never rebuilt a car. I never took shop. I should have. That's one regret I always had. But to be able to use something at a higher level means that you have to be able to recreate something. Not that you'll ever do it on a daily basis, or would it even be advisable to do so, but you do need to understand, when should I use this data structure? When is a loop going to cause 20 years of computation time because I'm doing it on a linked list, versus if I had used an array-based list, then it would only take a few seconds, right? You should be able to identify and analyze basic algorithms as well. Big O analysis, basically, right? Again, one of the themes of this course is smart data structures and dumb code are a lot better than the other way around. That's a quote by Eric S. Raymond, a book called The Cathedral and the Bazaar. If you ever want to get into reading books about development, about design, it's one that I would recommend. Another one that I just got done reading is The Philosophy of Software Design, I think it is, by Osterhut. I forget the author, but I can post it later if you want. It's not, there's definitely some warts and flaws in that book, but it's a nice little easy, digestible read on, and modernized read on how to approach design, from small things like variable names all the way up to dependency inversion, right? Unfortunately, he doesn't use a lot of well-established terminology for it, and that's one of the warts. But it is a good read, right? And these are some of the books that you'll want to read as a side project to understand your own craft better, your own discipline better. By the end of this course, you should be able to approach a reasonably complex problem and ask design questions first. What entities or objects would be appropriate to model this problem? How do these objects work and interact with each other to solve a problem? Do I use composition over there, right? A lot of people failed to put in a collection of sales in the salesperson class, for example. How in the hell are you ever going to compute how many sales a person has, or what their total sales total is, right? They did it outside the class, breaking encapsulation. You need to understand how these things work together and what the relationship between them is. That all came hopefully very, very clear when you designed your database, right? And normalized things. That was the true relationship there. What data structures would be the most appropriate or most efficient to use? Again, the first question you should ask yourself when problem solving in, say, Computer Science 1 is it already solved, right? And the CS2 version of that is, what data structure or algorithm can I pull off the shelf and tweak or use in some way to solve this problem? Heap sort, for example. Put stuff in, take stuff out, right? That's a perfect illustration of smart data structures and dumb code are a lot better than the other way around, right? All right. Again, the big takeaway is that you may have done some or a lot of things poorly, but next time you'll do better. Right? This is why we allowed the resubmission opportunity, because the folks that did stick with it and persisted all the way to the end, right? We wanted to give you an opportunity to amend your mistake sometime prior in the semester with that resubmission opportunity. Again, the first time you do things, it's always the hardest, right? The second time you do things, it is way less hard. The third, the fourth, the fifth time that you do something, it's like second nature, right? It's like it's like any skill. You can compare it to riding a bike. The first time you ride your bike, you're gonna fall. You're gonna fall a dozen times. But after that, it's like, right, you never forget, right? All right, so these are not final stats. These are pre-end stats. These do not include the last lab or the last 2 assignments. There were 159 total as of the census date enrolled in this course. And now this is including both the main section and the honor section. 26 ultimately withdrew. A minority of those that withdrew for personal reasons, like they just had too much workload, or they just couldn't handle, or it just wasn't what they wanted to do anymore. Unfortunately, the majority that withdrew because they were not going to pass the class. Fortunately, though, 66 people did end up are ending up right now, I should say, with A's, including 14 people, or 10% of the course nearly, with more than 100% because of all the available bonus. 36 B's, 13 C's, 3 D's, and 15 F's. So if we put withdrawn at the end there, you kind of see an inverted bell curve, which is unfortunately usual in computer science classes and a lot of STEM classes. Lots of high grades, lots of failures, right, or low grades. Unfortunately, that's the nature of the beast. That leads to a 27.7% DFW rate. Those are the percentage of students receiving a D, F, or ultimately withdrew from the course, which is a little bit higher than usual, a little bit higher than history, which has usually for this class, it's about 20% DFW, and we can attribute that maybe to COVID a little bit disconnection, and people not being able to, people having more of an aversion, again, for whatever reason, more of an aversion to hop on Zoom help hours versus if we actually had a physical lab, they would, be comfortable living down there or something like that, maybe. I don't know. You tell me. Why do you think we had a little bit higher than historical averages? Why do you think that the historical averages are high? Right, 20% failure rate. Why is that? Right. I have my theories, but I would like to hear your theories. Right? The course conclusion: you do have assignment 7 due tomorrow on Friday. Take care with your design. We've truly tried to drive home the point that you should be reading the rubric. You should be reading the handout. At the very end, we've got a frequently made mistakes section, right? Instead of frequently asked questions. Don't do any of those things, right? And you should be good. Again, assignment 7 is kind of a test, the ultimate test in your design skills. With what we've given you in class, literally, you should only have to write like 10 lines of code for assignment 7, as long as you are designing it correctly, right? What we're really testing on assignment 7 is not correctness. We're testing your design skills and how well you're able to recognize what is a sorted list, how do I go about maintaining an order rather than sorting, etc. Right? And what should the public interface be? Right? You should not be able to break your sorted list by arbitrarily inserting things, right? And what does that mean for your actual design? Literally, assignment 7 should be no more than 10 lines of original code if you've watched all the lectures, right? Your design document is also due on Friday. Again, review our feedback and retrospectives. The feedback that we've given you in Canvas, read the retrospectives that we've put on Piazza, because a lot of people have been ignoring those and not fixing those issues. That you should be giving context to your design. You need to be speaking about the business cases and the business model of this fake video game retail store chain, right? So that why did you subclass all your customers? What the hell is a gold customer, right? And people don't even mention discounts, right, in the introduction. There's no context for this. There's no way that even the most technically competent person in the world would be able to reproduce your design without that kind of information in your design document. There is no final exam. That was cut for COVID, and you know what? I'm going to cut it for the rest of my life. This is a skills-based course. It's not a memorization or facts or figures or whatever. It is a skills-based course, and how do you assess skills? By assigning stuff and doing stuff, right? And so the labs and the assignments, that's what I'm going to go for the rest, for the remainder of this. In fact, I'm even toying with the idea of eliminating the exams in Computer Science 1 next fall. Certainly, even if I retain them, they're going to be all-day exercises, so that those who really stress out about like that 1 hour or 2 hour time limit or whatever, don't worry about it. You got 24 hours, right? Assignment 8, there have been a couple of questions on that. Again, read the syllabus, read our posts on that. It's not graded, but it is necessary if you're going to go on through the rest of the program. We're going to, that it's part of this course, and we're going to assume that you have that knowledge that you could achieve, that you could fill out and do assignment 8, but we're not going to grade it. It's not due on Friday. You can go ahead and continue working on it over the summer if you want to, or whatever. But you should, convince yourself that you have that knowledge by at least outlining those solutions, right? Final stats, of course, will be posted. However, assignment 7 and 6, which will be posted today, and the design document turnout. I don't expect that much change here, though, right? If you've got an A, you're probably pretty solid on your A already, right? All right, so thank you. Thank you for taking this class. I want to thank all the students who helped on Piazza. You're beautiful. It is such a joy when somebody asks a question and then some other student answers it, and all I have to do is hit accept that answer. Right? Great answer. Good job. It really saves me on time. It's even the best answers are the ones that are just simply linking back to another answer already. So you can find these, these series of links that, well, somebody asked that question a long time ago. Here's the answer. Here's the answer again. Here's the answer again, right? Thank you for all the learning assistants and course leaders, everybody that helped grade, that did all the resubmission grades. They put in a lot of work this semester. So if you see your learning assistant, next semester, thank them. I put their pictures up. If you see them on Zoom the rest of this week, we do hold office hours through this Friday, but as of next week, no office hours. And thank them. Hopefully, you took my advice and you nominated one or more of them for the Learning Assistant Awards. And that will be announced, I think, next week. We'll see if any of them won. And thank you to the course leaders, of course, who supervise the learning assistants. I don't know if any of them watched the lecture, so I'll have to thank them again via text. Again, I want you to thank them as well if you see them, or just post on Piazza or something. Thanks to all the learning assistants. Thank you to everybody who took this class. This has been a really difficult and stressful year for everyone. Personally, I'm fine with it. Right? I've liked certain aspects about this weird, stressful year. I am a leaf on the wind. Everybody should be as well. Everybody survived, though, and next year we will thrive. So pat yourself on the back. Thank yourself for taking the course, and have a great summer. Any questions?
Well, I have a lot of questions for you about assignment 7.
Oh, sure. Go ahead and ask them. We're online here.
Oh, okay. Well, they're more so, I'm not sure that should be asking them online because they're kind of specific to my design.
Okay. All right. We'll take it offline then. All right. So again, will this make me understand tree data structures completely? No. You'll have to watch the other videos to do that. This was the course retrospective. Right. All right. Nobody on Piazza? At least 43 people were watching. They all might be just random internet goons, though. So have a good weekend. Have a good summer. And again, thanks.